Kia ora, year 12 and 13. In this video, I'm going to look at the identity problem on revision sheet part C. So it should be reasonably short. We're going to prove that 3 cos 4x minus 2 is equal to this expression here. Now, when I start doing an identity, the first thing I do is I look at both sides of the problem and I see where I'm going from and where I'm going to. And I think about 3 categories of things and what might help me, at least for the first step. And one of those is the double angle formulae. One is the compound angle formula. And one, if I get really desperate, is the links between sums and products. And when we're doing identities, we usually will be going from the sum to the product. But happily, in this case, we don't have to worry about sums to products. And what I'm going to be working with are my double angles. So we've got cosine of 4x, and we should look at that and think, oh, well, 4x is 2 times 2x. And so we're going to use the double angle formula for cosine. So that's your first clue. I want you to pause the video and choose which one of the cosine 2x formulas you might start with. Okay, so cos of 2x has got 3 versions. They'll all come in handy at different times. The first one, probably the least useful one, unless you're desperate, is cos squared x minus sine squared x. The next one is 1 minus 2 sine squared of x. And the last one is 2 cos squared of x minus 1. So in this case, we've seen that we've got cos of 4x, which we're going to break into this, 2 times 2x. And on the right-hand side, we want to end up with something with all cosines in it. So my hunch or intuition, which is really just what comes from lots of practice, is that I'm going to work with this one. So we're now going to break down cos of 4x into cos of 2 times 2x. Okay, so we have 3 cos of 4x minus 2 is equal to 3 times cos of 2 times 2x minus 2. So that equals 3 times 2 cos squared 2x minus 1, just applying my double angle formula. That gives me 6 cos squared of 2x minus 3 minus 2, which is going to give me 6 cos squared of 2x minus 5. Right, now we can break this out into 6 cos of 2x times cos of 2x minus 5. Now I've lost it on this slide, but if you look back at the start of the problem, we're heading towards 24 cos to the power of 4x, blah blah blah. So we're going to again do a substitution for cos of 2x, and I'm going to choose the one with 2 cos squared x minus 1. So we get 6 times 2 cos squared of x minus 1 times 2 cos squared of x minus 1 minus 5. So expanding this, I get 6 times 4 cos to the power of 4x. So that's that one done. This is just FOIL from back in year 9 or 10. And then I've got minus this one and this one. So minus 4 cos squared of x plus 1 minus 5. Right, expanding out the first two, I get 24 into cos to the power of 4x minus cos squared of x. Right, and I've got 6 plus 1 is 6 minus 5 plus 1 as required. So we're done. Now you might like to try playing around with starting on the right hand side and moving to the left, which is taking the scenic route, but you will get there. But this is probably the cleanest way to attack this identity. So because we've shown the two sides are equal, this is always true. That's the whole point of an identity. It doesn't matter what value of x I choose, those two things will be equal. Thanks for watching. I will do some more later on this afternoon.